So first of all, we are going to start with the rules of log functions. So first of all, we have the most basic rule of a log function. Log of ma is equal to the exponential function m in the power of n equals a. And that can help us in solving basic log equations, and it can even help us into changing exponentials into log form. Next of all, we have 2 and 3 which kind of go hand in hand. We have the fact that if you multiply a and b, it's the same as adding a and b if they have the same base. So in this case, if this was 2 and the both of the m's on that side were 2, you could in fact multiply a and b to give you ab. And the same applies for division. If your bases are the same, you could have a over b in order to simplify it. And next up, we have our fourth rule, which is basically the change of bases. If you have log m of a, you can change it into log of a over log of m. And our last rule is the power property, which basically tells us if you have a number at the beginning of your log, you can put a, which is your number, at the end in the power of n. For example, if this was 2, and if this was 2 as well, you would have log of m is 2 in the power of 2, which would be log m 4. So first of all, we are going to expand these two log equations, and we are going to use our rules to do so. We learned that if you divide, it's the same as subtracting. So in this case, we could do log of x, and our bases are 10 because we don't have a base given, so we just assume that the base is 10, minus log of, we just assume that the base is 10y. And that's how you will expand that. And in order to expand this, we're going to basically do the same thing, and except we're going to change the sign. So we're going to have log of, again, the base is going to be 10, and that's going to be x, so log of 10x plus log of 10y instead of minus. And next up, we are going to move on to a more complicated example. So first of all, we are going to subtract 6 from both sides, because we have to get the solid number on one side. So we're going to have 2. And we're going to have log of 7 x plus 1 equals 2. And next off, we are going to change this into an exponential function. So we're going to have 7 in the power of 2 equals x plus 1. Now 7 squared is 49. So we're going to have 49 equals x plus 1. And in order to get x by its own, we are going to subtract 1 from both sides. And if we subtract 1 from 49, we're going to get 48. And therefore, x equals 48. For our second example, we have negative 2 log of 4 n plus 5 equals 0. First of all, we have to write this as an exponential function. So we have 4 in the power of 0 equals n plus 5 in the power of 2. We know that anything in the power of 0 gives us 1, and we know that we can't have negative exponents, so we are going to write this as a fraction over 1. Next off, we must go back to the rules that we have for exponents. We know that anything in the power of negative 2 is the same as square rooting it. So we're going to have 1 equals 1 over the square root of n plus 5. In order to get rid of this, and that's in fact the 2 because it's positive, and in order to get rid of this, we can square both sides. So we have 1 equals 1 over n plus 5 because the 1 squared or just 1, and n plus 5 cancels it out. And next off, to get n by its own, we can multiply both sides by n plus 5. 1 times n plus 5 is just n plus 5, and that is going to simplify to 1. And in order to get n by its own, we are going to subtract 5 from both sides, which gives us n equals -4. Now we are going to do Polytope division in order to find the roots of a function. We use Polytope division when the exponent is bigger than squared, so when you have more than 2 roots. So in this case, we already have a root given, which is what we're going to divide it by. So we are going to put that on the side in 2 separate terms. And the top part is what we're going to be dividing. And we always write that on the bottom just as a reminder for ourselves. So we're going to have 27x cubed plus 9x squared minus 3x minus 10. And now we are going to begin dividing. So we are going to start by our x cubed, and we are always going to put that in the top box. And then we ask ourselves, 3 times what gives us 27x cubed? And the answer to that is 9x squared. And next off, we have to multiply those 2 terms. So we have 9x squared times -2. That is going to give us -18x squared. Now we have to ask ourselves, -18x squared plus what is going to give us 9x squared? And after you think about it, the answer is 27x squared. So you're going to write 27x squared in that box. And then you have to divide 27 by 3 to get the top part. And for that, you're also going to get 9x. Except this time, instead of it being 9x squared, it's just 9x. And now, -2 times 9 is going to give you -18x. And now, you again ask yourself, -18x plus what is going to give us -3x? And the answer to that is +15x. And now we have to go back and ask ourselves, 15 divided by 3, what does it give us? And we get 5. And lastly, we have to multiply 5 times 2. And in this case, we get -10, which means that we have no remainder. Basically, the top part is going to be our solution. So we have 9x squared plus 9x plus 5. And now what you'll notice is that that doesn't give you the root itself. So in that case, you'd have to factor it. So you'd use the quadratic formula, and that's how you're going to get the roots using Polytope division. Right now, we are going to construct a unit circle. So here, I drew a circle, and now we have to divide it into 4 quadrants. So what I'm going to do is I'm going to draw 2 lines horizontally and vertically through the middle. And I'm going to continue this. This is the x-axis, and this is the y-axis. Now we have to divide our unit circle up a bit more. Each quadrant, quadrant 1, quadrant 2, quadrant 3, and quadrant 4, are going to be divided up into 4 triangles. So first of all, draw a line dividing each quadrant in 2. And next off, draw lines which are closer to the second line you drew than to the first line that you drew. So just like this. And repeat the same for the other side. And now you have quadrant 1 and 3 completed. Now you have to do quadrant 2 and quadrant 4. Next up, you're going to label the degree. And I'm going to use this green color to label each degree. So each of this have 15 degrees, and each of the bigger triangles have 30 degrees. So we start off by 30 degrees, and then we go to 45, 60. And we already know that that is 90 degrees, so that's going to be 90. And then you do 90 plus 30 degrees, which is going to give you 110 degrees, 120 degrees, and next up we have 135 degrees and 150 degrees, and that's going to be 180 degrees. Next up we're going to continue. 180 plus 30 degrees is 210 degrees, 210 plus 15, 225, and 225 plus 15, 240 degrees, and that's going to be 270 degrees. That's going to be 300 degrees, 315, 330, and that's going to be 0 degrees as well as 360 degrees. So now we are going to write each of them as radians. An easy way to put radians on a unit circle is by using the formula to convert degrees into radians. If not, you could memorize every single radian on its own. Now, I'm going to give you guys an example. Let's use 270 degrees, which falls right there. So we're going to substitute 270 degrees, and then we're going to have pi, because it's basically 270 over 1 times pi over 180. And now we're going to simplify, which is going to leave us with 3 pi over 2. And that is basically how you would find the radians. So now we are going to write the cosine and sine values on the unit circle. Now usually you would write the radians, the angle measurements, and the sines and cosines on the same unit circle, but to save space and make it less confusing, I erased the angle degrees that I had, and now I'm going to start over with the cosine and sine values. So, it's important to know that cosine sine is written as cosine, comma, sine. And it also requires a tiny bit of memorization. So we're going to start off by a 30-degree angle. And you should always memorize that that is radical 3 over 2 for the cosine value and 1/2 for the sine value. And next up we're going to move on, and I'm going to basically give you the values for each of them and then explain the patterns that we have. So we have radical 2 over 2, comma radical 2 over 2. And next up we have 1/2, comma radical 3 over 2. Now we're going to skip the basically like the main axis, and I'll come back to those at the end. So now the pattern is going to basically be the same. We are going to only have those 3 values, and now all we need to know is how to determine which sign corresponds to which quadrant. You could use the rules of a basic graph, or you could use the phrase all students take classes. So, this is for the first quadrant, this is for the second, third, and fourth quadrant. A means that every single value is going to be positive, as you can see. S means that only the sine value, the second values, are going to be positive. T means that only the tangent values are going to be positive, but the tangent values aren't usually in a unit circle, so we are going to skip them for now. And then we have C, which is for cosine, which means that in the fourth quadrant, only the cosine values are going to be positive. So now we're going to move on to the main axis, as I like to call them. This, you have to kind of memorize this, and if not, you can use the cosine SOHCAHTOA formula. So for the top, it's going to be 0, 1, and for the bottom, it's going to be 0, -1. Now we have 2 of the axes left, and this is 1, 0, and this is -1, 0. And for these 4 values, as you can see, these two are basically the same except the sign being switched, and these two are basically the same again with the sign being switched. So now we're going to move on to the rest of the values. So as I explained before, in this quadrant, only the sign values are going to be positive. So we have our cosine values, -1/2, and our sine values, radical 3 over 2. And next up we have radical 2 over 2 and comma, the same value. And a pattern that you're going to notice is that these are basically repeated. So it goes from radical 3 over 2 all the way to 1/2, and then it's basically the same pattern, and it comes down, so those values are each the same except with the signs. So all you have to basically memorize are where the signs go and the basic values. And the good thing is that for the third and fourth quadrant, the same rule is also followed. So, as you can see, only tangent is positive, so both values are going to be negative in this quadrant. So we have negative rad 3 over 2, comma, -1/2, negative rad 2 over 2, comma, negative rad 2 over 2. And lastly, we have -1/2, negative radical 3 over 2. And now we're going to move on to the last quadrant, which again follows the rules of the same quadrants as before, except this time the cosine value is going to be positive. So we have +1/2, negative radical 3 over 2, positive rad 2 over 2, comma, negative rad 2 over 2, and the last value is going to be radical 3 over 2 and -1/2.